Hello, as you can see in this question, it is asked a car driver sharply presses down the accelerator when the traffic lights go green. So he pressed the accelerator suddenly when the light went green. The resultant horizontal force acting on the car varies with the time as shown. So this is the force and this is time with time, how it varies. This is the horizontal force. Okay, suddenly it was accelerated, so a sharp increase in the force from zero. At the beginning, it was at rest, right? It was at rest, v is equal to zero. So here there is no force exerted. But suddenly, all of the sudden, he pressed the accelerator, so force sharply increased along the horizon. And then after this point, the force was constant. The force was constant. Now, they're asking which graph shows the variation with time of time of the speed of the car. Basically, S versus sorry, V versus T graph. We have to find which suits this scenario. So if I want to draw S versus or sorry V versus T graph or speed versus time graph after this point, so it will look like this. V versus T would look like this. Since or maybe somewhat like this. Okay, linear graph. Basically, what I am to say, linear graph. Why? After this point, accelerate this force is constant, right? That means acceleration is also constant. Acceleration constant means uniform motion. So we'll see a linear graph, right? In velocity versus time graph. So we are sure here we will see a linear graph. So nothing in this one or in this one shows a linear graph like this after this point. Okay, so these are wrong. And this one as well, B, it is showing this curved graph, right? In the later half, which is not correct as well. It's supposed to show a linear graph. Here, as you can see, after this point, the graph is linear. That means uniform acceleration, that means uniform force. And here, if I draw a graph here, speed versus time, speed versus velocity, time graphs. Here we'll see non-uniform acceleration, right? So it will be somewhat like this curved. So the graph will be from here to here curved, then linear graph. So this is the perfect fit, or all it this graph almost fits this scenario. So option number A is the correct answer.